One of the things that I preach over and over is the idea that all stoichiometry problems are essentially the same. The key factor within those stoichiometry problems, even if you start with different quantities, is that you need moles. And so no matter what you're given, like if you're given moles, good. If you're given grams, you're going to have to turn it into moles. And if you're given a volume and a concentration, you're going to have to turn it into moles. Then if you had a gas, you could have like a volume, a temperature, and a pressure, or something like that. And what I want to do with this problem is take a look at a specific chemical reaction, and we're going to look at calculating the limiting and excess reactant based on different starting quantities, moles and grams and milliliters. And what you're going to notice is as we do the problem, once we get moles, the work is exactly the same. And in this particular problem, I set it up so there's another not so surprising surprise. The way I've been teaching stoichiometry problems is to set up a table of what you have and what you need. We need to compare the reactants to each other, and I've taken the time to color code these reactants. The copper 2-bromide is going to be blue, and the sodium phosphate is going to be green. And I am a little cramped for space here because of my awesome planning, but we can make it work. I'm going to compare the reactants to each other. So in this particular case, I have 0.113 moles of copper 2-bromide. All right? And we know from our balanced chemical equation for every 3 moles of copper 2-bromide, I'm going to sneak that in right here right away, we have 2 moles of sodium phosphate. And our starting amount for the sodium phosphate was 0.0563 moles. All right, we got it to fit. We are trying to find out what we need for each of these things, because comparing our have and our need is how we figure out which is the limiting reactant, the one we don't have enough of, and which one is the excess reactant, the one we have more than enough of. So as we run through this calculation, 0.113 times 2 divided by 3, we end up with 0.075 moles of sodium phosphate that we need. And when we take our 0.0563 times 3 divided by 2, we end up with 0.0844 moles of the copper 2-bromide. And now we begin that process of identifying which is our limiting reactant and which is our excess reactant. I have 0.113 of the copper bromide. I need 0.08 of the copper bromide, and that means I have way more than I need. This top one's going to be our excess reactant. And then as we look down, 0.0563 is what I have of the sodium phosphate. I need 0.075, all right? So I have 0.05, I need 0.07. I don't have enough. That one's going to be my limiting reactant. I'm going to try and color code these answers here in terms of limiting reactant. In this particular case, we just said the sodium phosphate was the limiting reactant. And we said that the copper 2-bromide was the excess reactant. I will abbreviate that as I write it here. We've got the excess reactant and the limiting reactant, and that is the answer to the question we were asked. And that's the most fundamentally simple stoichiometry problem where you're given moles and moles. We'll have one extra step for each of those, but this is going to be exactly the same because, as you may recall me saying, all stoichiometry is pretty much the same. Since these are all the same, I went ahead and wrote out the exact same work for every single one of them, and that is the stoichiometry, the ratios from the balanced chemical equation. We had whatever's given, and I left room so we could calculate those things in moles. Everything after the first box came from the balanced chemical equation. That's 2 moles of Na3PO4, 3 moles of CuBr2. And the same deal here and here, because they're all exactly the same. I did forget this one. All right. So during that pause, there was quite a bit of monotonous writing, but again, that just highlights the fact that as soon as you have moles, all stoichiometry is the same. So what we're going to do right here is deal with grams. One of the things you practiced earlier in the year was turning grams into moles, and you do that by dividing by the molar mass. So as a quick reminder, moles is the mass over the molar mass. So for each of these over here, we're going to take the masses that are given divided by the molar masses that I supplied in this particular case. You could add them up and get them, but I saved you some time. So for the first one, we have 25.24 grams of copper bromide, and we're going to divide that by 223.37 grams per mole. And by no coincidence, we end up with 0.113 moles of copper 2 bromide. So I'm going to write that number, 0.113, right there. For the sodium phosphate, we got 9.23 grams. We're going to divide by its molar mass, which is 163.94. And that gives us, shocker, 0.0563 moles of sodium phosphate. Now, the reason I said shocker is because I set these numbers up intentionally so we would end up with the same number of moles. Now, in a different problem, you'd probably be given amounts that didn't match that way, and you wouldn't always get the same number of moles here and here, and spoiler alert, I'm going to end up with 0.113 and 0.0563 when I evaluate this. But for this particular problem, I wanted to show that no matter how you start, once you get to moles, the calculation is the same, even though these numbers may end up differently. For this one then, we end up with, again, 0.075 moles of Na3PO4. And for the copper bromide, we end up with 0.0844 moles. So, once again, you have 0.05, you need 0.07, you don't have enough. That becomes our limiting reactant. You have 0.1 and you need 0.08, that becomes our excess reactant. And we'll write that off to the side as we did before. And I do want to point out again, the only reason these two numbers are the same here and here is because I set it up that way. Because I wanted to show this. They won't necessarily happen like that out in the wild. The last one here that we need to deal with is these volumes and concentrations. And one of the other equations you know is that molarity is moles over volume in liters. And in this particular case, we have molarity and volume in liters, so we can get moles as the molarity times the volume in liters. And we'll do that for both of these. We have for the copper 2 bromide 0.150 molar times 0.750 liters, and there's a quick sleight of hand turning milliliters into liters, and we end up with 0.113 moles of that copper 2 bromide. And that's 0.113 right there. And just while I have the blue pen out, 0.0844. As you look at the sodium phosphate, we have 450 milliliters, 0.125 molar. And again, turning milliliters into liters, it ends up 0.0563 moles of sodium phosphate. So right here, 0.0563, and we end up with 0.075. This one, once again, have 0.05, need 0.07, don't have enough. That's our limiting reactant. This one, have 0.1, need 0.08. So we've actually got too much, and that gives us our limiting reactant and our excess reactant. And I'll set up another video where they aren't all the same, and that's a little more realistic.